Welcome to Memory Lesson 2. Features of each store in terms of coding, capacity and duration. My name is Nick Redshaw and I have over 16 years experience of teaching A-level psychology. I'm also co-author of the highly successful student series of workbooks exclusively available on Amazon. Okay, to get you thinking, have a go at this word search. You may want to pause the video at this point just to complete this word search. Okay, welcome back. So, short-term memory. There it is. Long-term memory. Well, actually this one, come down here and then you join it here. Long-term encoding. Hopefully you've found it here. Capacity, easy one, up here. Duration, down here, slightly trickier one. Acoustic, in reverse, here. Semantic, down here. And cognitive. Here. Okay. So, moving on. You'll recall from the last section on the multi-store model of memory by Atkinson and Schifrin that memory is divided into 3 stores: sensory register, short-term memory, and long-term memory. These stores differ in terms of 3 important features. Coding. This is where information is coded, creating a memory trace which can then be processed in the memory store. Capacity. This is the measurement of how much information can be held in a memory store. And duration. How long information is held in each store. The diagram below outlines how the features of coding, capacity and duration differ within each memory store. So the sensory register. Coding here, information is registered by the senses and as such is modality specific, e.g. different stores for each sense. The capacity is unlimited and the duration only lasts for approximately 200 to 500 milliseconds before it fades away. Short-term memory. Coding. Information is registered acoustically, i.e. based on the sound of the word. The capacity, a limited capacity of 7 plus or minus 2 items. Duration, a short duration of about 18 to 30 seconds. And long-term memory. Coding. Information is registered semantically, i.e. based on the meaning of the word. Capacity, unlimited, and the duration of potentially forever. These key differences in the features support Atkinson and Schifrin's claim that there are 3 distinct memory stores, as they highlight that information is processed and stored in different ways in each memory store. Okay, if you're using one of our workbooks, or if your teacher has downloaded our workbook from TESS, then complete the following table. Or, if you're not, on a piece of paper, complete the following table. You may want to pause your video at this point. Okay, welcome back. So, long-term memory. The capacity of long-term memory, A. Hopefully here you've said unlimited. The sensory register duration, hopefully here you've said 200 to 500 milliseconds. And the coding of sensory register, if you remember, modality specific, e.g. different stores for each sense. And finally D, short-term memory duration, about 18 to 30 seconds. Okay, moving on to the next true or false. Information in short-term memory is coded acoustically. Information in short-term memory is coded acoustically, true or false. Nice and quick one here. Hopefully you've said here, true. The duration of long-term memory is unlimited. The duration of long-term memory is unlimited. Now here, this is a tricky one. Students often say unlimited, but unlimited is a capacity word. So really, I mean, you're looking here for potentially forever. Okay, so this one would be false, potentially forever. Okay, for 6 marks then, outline the multi-store model of memory. In your answer, make reference to the key features of each memory store. Now, in the exam, I mean, general rule of thumb, mark a minute. So I mean 6 minutes you want to spend on this, so you'll want to pause the video at this point. Outline the multi-store model of memory. In your answer, make reference to the key features of each memory store. Okay, welcome back. So for the top band here, knowledge of the multi-store model should be generally accurate and well detailed. The answer should be clear and coherent, and you should make appropriate reference to the key features of each store, and specialist terminology is used. Probably, I mean, a good thing to bear in mind here is a lot of textbooks and a lot of sort of teachers possibly only focus on short-term memory and long-term memory. Each store is what the specification says. So that's the sensory store, short-term store, long-term store. Okay, so your answer should be somewhere along the lines of Atkinson and Schiffer in 1968 claimed that memory is like an information processing system where data flows in a linear direction through 3 distinct structures. Firstly, the sensory register, SR, then through attention to short-term memory, and through rehearsal to long-term memory. These stores differ in terms of 3 important features. Firstly, coding. This is creating a memory trace that can be processed by the store. In terms of the SR, information is coded by each sense, and as such is modality specific. The coding of short-term memory is acoustic, i.e. based on the sound of the word, and for long-term memory it's semantic, i.e. based on the meaning of the word. Secondly, capacity. This is the measurement of how much the store can hold. The capacity of the SR and LTM is said to be unlimited, whereas the STM is said to have a limited capacity of 7 plus or minus 2. The final feature is duration. This is how long information can be held in each store. The duration of the SR lasts for approximately 200 to 500 milliseconds before it fades away. The duration of STM is 18 to 30 seconds. The duration of LTM is potentially forever. If the processes are successful, information is remembered. If not, it is forgotten. So the emphasis of this model is on the structure and processes of memory. Quite a bit of information there, but a good solid 6 marks. Okay, little breather for you. Have a go at this crossword, the multi-store model of memory. Again, you may want to pause your video at this point. Okay, welcome back. So, 1 down is memory. 3 across is retrieval. 2 down is rehearsal. 4 across is semantic. 5 down is attention. 7 across is sensory memory. 8 down, obviously we've given you, is encoding. 6 down is duration. 9 across is capacity. 10 across is acoustic. And 11 down is storage. We'll now look at each memory store in more detail in terms of the research studies that demonstrated the difference between the sensory register, short-term and long-term. The sensory register, as I've already mentioned, often overlooked by books and schools. The coding of sensory register is through the 5 senses, with each having its own memory trace. Therefore it is modality specific, with each sense creating its own chemical message. The diagram opposite outlines each different sensory memory and the information they deal with. Research has shown the duration of the sensory register is very short. typically only lasting in the region of 200 to 500 milliseconds. However, further research has now shown that echoic memory is now thought to last a little longer, up to perhaps 3 or 4 seconds. So the diagram: iconic memory, information that deals with visual information; taste memory, obviously deals with taste; olfactory, deals with smell; echoic, deals with auditory; and haptic, deals with tactile, touch information. Laboratory experiments by George Sperling in the early 1960s involving the flashing of a grid of letters for a very short period of time, 50 milliseconds, suggest that the capacity of sensory register is approximately 12 items, although participants often reported they seemed to see more than they could actually report. Therefore, it is generally accepted that the capacity of the sensory register is unlimited. This slide has key terms, obviously, which we've covered already on what capacity, duration and coding means. Research into the duration of short-term and long-term memory. Further support for the difference between the memory stores comes from the following research studies into the duration of memory. Peterson and Peterson in 1959 looked at the duration of short-term memory. Their aim: to prove that information is only held in short-term memory for about 20 seconds. After that, it disappears if rehearsal is prevented. The procedures. They used a lab experiment. Participants were presented with sets of trigrams, nonsense syllables in sets of 3, e.g. BCM. In a repeated measures design, they were asked to recall the trigrams in serial order after a delay of 3, 6, 9, 12, 15 and 18 seconds. Participants were given an interference task of counting backwards in threes from a random 3-digit number to prevent rehearsal. Recall had to be 100% accurate and in the correct order for it to count as correctly recalled. The results: after 3 seconds, there was 90% recall; after 6 seconds, 50% recall; and after 18 seconds, only 2% recall. And obviously we've got a graph there showing you the results. So, from that graph, what conclusions can you draw from the descriptive statistics about the duration of short-term memory? Okay, again, you may want to pause your video at this point. Okay, so welcome back. Marks here, 2 marks of AO3. What conclusions can you draw from the descriptive statistics about the duration of short-term memory? So for 2 marks, the researcher might conclude that the duration of short-term memory is approximately 18 to 30 seconds, with participants at the start recalling 90% of the trigrams correctly, but this decreases rapidly with every 3-second retention interval. After 18 seconds, only 2% can be recalled in the correct order. Thus, the duration of short-term memory is short. Okay, the next question. State the independent variable and the dependent variable in Peterson and Peterson's study for 2 marks. Again, if you want to pause the video. Okay, welcome back. It's worth pointing out here, whilst there's only 2 marks, i.e. for each correctly identified, it is worth noting that in the past exams, students have needed to operationalize the variables, i.e. simply saying how they are measured. So, the first one then, the independent variable, is the 3-second retention intervals. 3 second obviously is the operationalizing. 1 mark for the dependent variable is the number of trigrams recalled. Recall what they remembered in the correct order. Again, number. The number is the operationalized bit there. So not a lot to put in, but obviously just make sure you do, because in previous exams, examiners have been very strict. Okay, the next question then. The experimental design used in Peterson and Peterson's research was a repeated measures design. A repeated measures design. Okay, the answer here, hopefully you've got, is true. True, because obviously the same participants are taking part in the 3-second interval, the 6-second interval, the 9-second interval. Okay, then the next question, outline one advantage and one disadvantage of the experimental design used. One advantage and one disadvantage. Again, you may want to pause your video at this point. Okay, so up to 2 marks for the outline of each advantage and disadvantage here, and a further 2 marks for elaboration and linking them to the research. So obviously just listing an advantage of the experimental design but not mentioning Peterson and Peterson will only score you half marks. Okay, so advantages here could include, as the same participants are used in each condition, the effects of individual differences are controlled. So any changes in the DV, the number of trigrams, that's linking it to the research, correctly recalled is due to the IV, the 3-second retention interval, and not participant variables. Disadvantage, the second condition can be affected by order effects such as practice effect, fatigue or boredom. As the participants are taking part in 6 conditions, they are likely to become tired and lose concentration. Thus it may be this, rather than the duration of short-term memory, causing the declining performance. Okay, the next question. The interference task was used to control for rehearsal, which would have improved recall and confounded results. True or false? Okay, the answer here is true. Explain why it is appropriate to use a line chart to display the results of Peterson and Peterson's study. Okay, for 2 marks here then, a clear explanation of why it was appropriate to use a line chart to display the results of Peterson and Peterson's study. Line graphs are often used to show a trend over time, i.e. number of days, hours, minutes or seconds, therefore represents continuous data. Therefore, as Peterson and Peterson's research 3-second, 6-second retention intervals, a line graph is the most appropriate graph. Okay, moving on. It was important that Peterson and Peterson's study used nonsense trigrams as opposed to words that have meaning, as this can be recalled as wholes. Recognizable abbreviations and acronyms, as these are meaning and again can be recalled as wholes. Multiple repetitions and rhyming letters, as these are easier to remember. All of these would have acted as a confounding variable, as they would have improved recall, reducing the validity of the findings. Okay, by way of evaluation, and again in the exam, you could be asked to outline one study into the duration, or discuss one study into the duration. So you'd need to outline Peterson and Peterson's research and then evaluate. So strengths, this was a laboratory experiment with high levels of control, so it's possible to repeat the study easily, improving its reliability. Cause and effect can be established, so it can be concluded that time delay causing recall to decline. Peterson and Peterson's study paved the way for further research into short-term memory duration. Murdoch in 1961 found the same levels of recall as the trigrams when using 3 unrelated words, so supporting the claim that short-term memory has limited duration, even with more meaningful information. Limitations. This was a lab-based experiment and the results may not be generalized outside that setting and therefore lacks ecological validity. Trigrams are artificial things to remember and do not reflect the way we use memory in everyday life, so lacks mundane realism. Sebrax et al. 1989 found that when participants are not expecting to be tested, the duration of short-term memory decreases, even further highlighting participant reactivity in the original research. Peterson and Peterson's study clearly shows the duration of short-term memory is short. We'll now need to look at the duration of long-term memory. Barrick et al. In 1975 looked at their high school yearbook study on the duration of long-term memory. The aim, to investigate the duration of very long-term memory, VLTM. The procedure, a field experiment. An opportunity sample of 392 American ex-high school students aged between 17 and 74. Recall was tested in a number of ways. Here are two examples. A photo recognition test, where they were asked to identify former classmates in a set of 50 photos without being given a list of possible names, i.e. recall group. A name and photo matching test, where they were given a list of names and they were asked to match the names on the photos, recognition group. This was designed to test very long-term memories, as time since departing high school varied. For some it was as long as 48 years. It was assessed by comparing their responses with high school yearbooks, which contained all the names and photos of the students in that year. The results. Table 1. Time since graduation and recognition of classmates' photos. Years after graduation, 14, 90%, 25 years, 80%, 34 years, 75%, 47 years, 60%. Table 2. Time since graduation and recall of classmate names with no pictures. Years after graduation, 7 years, 60%, 47 years, 20%. Okay, here you've got something slightly different. You need to be able to draw a suitable type of graph or chart to illustrate the data in Table 2. Draw a suitable type of graph or chart to illustrate the data in Table 2. So if you're using one of our workbooks, obviously you've got the graph paper. If not, draw on a piece of paper that you've been provided with. So if we go back, there's Table 2 there. Okay, so welcome back. So your graph should look something like that. 7 years, 47 years. Should have a title, and your title should be sort of like along the lines of graph 1. A bar chart showing time since graduation and recall of classmates' names with no pictures. Along here. %, and so on. 20, 40, 60, 80. So the title of this would be percentage recall, and along here, years since graduation. What conclusions can you draw from the descriptive statistics about the duration of long-term memory for 2 marks? Again, you may want to pause the video at this point. Okay, welcome back. So for 2 marks, the researcher might conclude that the duration of long-term memory is long, as the participants in the recall of classmates with pictures were still 60% after 47 years. And even in the condition with no pictures, participants could still remember 20% of information after 47 years. So, complete the following sentence. Tick 1 box only. The dependent variable in Barak et al.'s study is A. Measured by the researcher, B. The number of names or faces correctly recalled, C. The age of the participant, or D. The recognition and recall group. Well, hopefully here you've ticked B. The number of names and faces correctly recalled. The dependent variable is always the outcome, always the result, always the number of something. Okay, the next question. Outline the difference between short-term memory and long-term memory in relation to duration and refer to research in your answer. Again, you may want to pause the video at this point. Okay, welcome back. So, difference between short-term and long-term memory in relation to duration. 4 marks. Simply here, the duration of short-term memory is much shorter than long-term memory, as it only lasts for 18 to 30 seconds, as shown by Peterson and Peterson's 1959 research, compared to long-term memory, which lasts potentially forever, as shown by Barrick et al.'s 1975 study, which found that the duration of long-term memory is as long as the participants still have 60% recall after 47 years or 20% recall after 47 years. Evaluation here. Strengths. The memory task has good ecological validity as it asks participants to recall their classmates, which are real life memories, and reflects the way in which we use memory in everyday life. The sample was very large and is likely to reflect a great deal of diversity. Barrick et al.'s study paved the way for further research into long-term memory. Limitations. This was a field experiment, which means it is difficult to control for confounding variables. For example, the individual may have had contact with their classmates since leaving high school. This means that the findings might not be valid. The study was conducted on American undergraduates, so it is difficult to generalize the findings to a wider population. Okay, here you've got a web task. Complete the following web task. Note the box is small, so we don't expect you to write a lot of information, 1 sentence or 2. Okay, so you need to go on Google, you need to sort of like look this up. Complete the following web task. Okay, you may want to pause this. This may take you a small amount of time. Okay, welcome back. So, Barrick and Hall's 1991 study. And I've had teachers email and say, can't find this one. Well, I just cut and paste it into Google and it comes up straight away. So, it is findable. However, Barrick and Hall 1991 found that participants can remember the algebra they learnt from school many years later. A refresher course brought their skills back to a high standard very quickly. They also found that a delirious person can use a language that they have not spoken since their childhood. Conclusion: these findings show memories in long term last a long time. Therefore, does it support Barrick et al.'s original study? The answer is yes. Shepherd, 1967, tested the duration of long-term memory, showing participants pictures, then putting some of those pictures in with other pictures that have not been seen before. The participants got almost perfect recognition. After a few months, participants still remembered 50%. Conclusions: these findings show that memories in long term last a long time. Does it support Barrick et al.'s original study? Yes, it does. Okay, moving on. Research into the capacity of short-term memory and long-term memory. Additional support for the difference between the memory stores come from the following research studies into the capacity of memory. The first research study looking at the capacity was carried out by Jacobs in 1887, and this was later followed by Miller in 1956. Both concluded that the capacity of short-term memory was 7 plus or minus 2, known as Miller's magic number. Even when information was chunked, participants were still only able to recall 7 plus or minus 2 chunks. So Miller's 1956 study into the capacity of short-term memory. Aim: to prove the capacity digit span of short-term memory is limited to 7 plus or minus 2 items. The procedures: Miller used a lab experiment using the digital span technique. Participants were presented with a number of digits or letters that they were asked to recall in the same order that they were presented. The participants started with 3 digits to start with, and then 1 digit was added on each subsequent trial. The maximum number of digits that a participant repeated backwards correctly was the measure of their digit span. Results: Miller established that the digit span of participants was between 5 and 9 and an average of 7. Miller also found that this applied to chunks of information. In addition, he also found that the digit span increased with age from 6.6 at 8 years to 8.6 at 19 years of age. Conclusion. Miller concluded the capacity of short-term memory was extremely small and coined the phrase 7 plus or minus 2, Miller's magic number. It also extends to what Miller referred to as chunks of information. Key term here, chunking. So here's a question for you, and you're given a little scenario, and this is quite likely in the exam. A researcher carried out an experiment to investigate how many numbers could be held in short-term memory. The participants were 15 children and 15 adults. Participants were asked to repeat lists of random numbers in the correct order as soon as they were read out by the researcher. For example, when the researcher said 3, 4, 2, 8, the participants immediately repeated 3, 4, 2, 8. When the researcher then said 7, 5, 9, 6, 4, the participants immediately repeated 7, 5, 9, 6, 4. One number was added to the list each time until participants were unable to recall the list correctly. Each participant's maximum digit span was recorded. Okay, so firstly, write an appropriate non-directional hypothesis for this experiment, and you may want to pause the video at this point in order to do so. Write an appropriate non-directional hypothesis for this experiment. Okay, welcome back. So non-directional, there will be a difference between the children and adults in the number of lists repeated in the correct order. The reason that's non-directional is it's not saying whether it's more or less. You're just saying there'll be a difference. There will be a difference between the children and adults in the number of lists repeated in the correct order. That's 2 marks. Explain why the researcher used an independent group design for this experiment. For 2 marks. Okay, an independent group design was used. The researcher is interested in the difference between 2 groups, children and adults. The only design they could use is an independent group design, i.e. different participants in each condition, the children in one condition and the adults in the other condition. Part C. Using the frequency graph, write the mode of each group in the table below. So this is one of your mathematical requirement questions. Mode. Now mode is the most frequently occurring number. So if we look for children, this is the orange line, and it reaches its peak at 6. So obviously the answer is 6 for children, and for adults it reaches its peak. So the 7 so the answer is 7. Outline one advantage and one disadvantage of the experimental method used by Miller in 1956. 4 marks. So, outline one advantage and one disadvantage of the experimental method used by Miller. So, experimental method, lab experiment. So, simply here, an advantage of a lab experiment is that it allows for precise control of all variables. So we can conclude that it's the IV, the age of the participant, and nothing else which is influencing the DV, the maximum number of digits recalled correctly. Number of advantages or disadvantages you could use here. So advantages allows for precise control of all variables. Another one, highly scientific. High level of control makes it easy to replicate. Standardized procedures, instructions and control of extraneous variables. all possible sort of ones here, but obviously link it back to the study. Disadvantage: they're not typical of real life. As a lab setting, it is artificial, lacks ecological validity, and again link it back to the study. Demand characteristics: major issue. Tasks involved are often boring and meaningless, and possible ethical issues. Explain why Miller's 1956 research lacks ecological validity. Okay, 2 marks here. For clear explanation of why Miller's study lacks ecological validity, the task of repeating random numbers in Miller's 1956 study is not typical of real life. As a lab setting, it is artificial, therefore lacks ecological validity, so it can be criticised for being low in external validity, i.e. not testing what it should be testing, making it hard to generalise the findings. Okay, your next question. Postcodes are an example of information remembered by chunking. Give 2 further examples for 2 marks. Okay, here, telephone numbers, the code for a house alarm, and so on and so on. Okay, just 2 examples, simple as that. Telephone numbers, code for a house alarm. Okay, research carried out by Baddeley et al. 1975 found evidence against Miller's magic number. They found that participants were able to record considerably more short words than long words. This suggests that short-term memory capacity was capable of dealing with small pieces of information, but recall dropped the longer the words took to process. Bauer and Winzes 1969 highlighted the difficulty of excluding long-term memory when testing short-term memory. When short-term memory tests are repeated, they become increasingly easier, suggesting long-term memory helps to increase short-term memory capacity. Therefore, the research may lack validity, as it may not be testing what it claims to be testing, i.e. it cannot rule out the influence of long-term memory as a confounding variable. Okay, so again here you've got one of the complete the following web tasks, and again note the boxes are small, so we don't expect you to write a lot of information. Again, 1 sentence or 2. You may want to pause the video, and again typing the actual researchers' names into Google, good way of finding the information. Okay, welcome back. So Spikart and Boroff 1986 found that the performance on the memory span task is equivalent to the number of items that can be pronounced in about 2 seconds. The best indicator of short-term memory is time rather than capacity. Does it support Miller's original study? The answer is no. Navarre, Benjamin and Ayres 1986 found that the digit span was larger for languages in which speech rate, as estimated by reading speed, was faster. The best indicator of short-term memory is speech rate, time, rather than capacity. Does it support Miller's original study? The answer is no. In contrast to short-term memory, long-term memory capacity is thought to be unlimited. As to date, no research has found any limits on the amount of information long-term memory can hold. Okay, you may want a short break at this point, make yourself a cup of tea or something like that, or just continue sort of listening. Research into the coding of short-term memory and long-term memory. The following research study by Baddeley 1966 looks at coding in both short-term memory and long-term memory. Baddeley 1966 study of coding in short-term memory and long-term memory. The aim: to investigate coding in short-term memory and long-term memory, and to establish that short-term memory is coded acoustically and long-term memory is coded semantically, as previously predicted by Conrad in 1964. The procedure: a lab experiment was used. Participants were divided into 4 groups in an independent group design. The groups were given lists of 5 words to remember were either acoustically similar or dissimilar or semantically similar or dissimilar. 2 of the lists were the experimental conditions: acoustically similar, meat, feet, sweet, and semantically similar, neat, tidy, clean. The other 2 lists acted as a control list and were acoustically dissimilar: pen, cow, hot, and semantically dissimilar: safe, deep, late. One group were asked to recall the word list immediately, testing short-term memory, and the other group were asked to recall the list after 20 minutes, testing long-term memory. The results are summarized in the tables on the screen. Table 1 results for short-term memory. The amount of words recalled were tested immediately after presentation. So the words, acoustically similar, 55% accurate. Acoustically dissimilar, 75% accurate. Acoustically dissimilar words were recalled significantly more accurately than acoustically similar words. Table 2, the results of long-term memory. Amount of words recalled after short intervals of 20 minutes. Semantically similar, 55%. Semantically dissimilar, 85%. Semantically dissimilar words were recalled significantly more accurately than semantically similar words. Conclusions. The greater inaccuracy of acoustically similar words suggests that short-term memory relies on the sound of information to store the information. And the greater inaccuracy of semantically similar words suggests that long-term relies on the meaning of information to store the information. So another question for you. Outline one advantage and one disadvantage of the experimental design used by Baddeley for 4 marks. Okay, the answer here. Advantages. As participants only took part in one condition, they are less likely to experience order effects such as boredom, fatigue and practice effect, or you could have had the same materials you used for both conditions. So for example, harder or easier words would not become a confounding variable in this design. Disadvantages. Individual differences between the two groups will be a problem here. For example, if one group was more alert than the other, this would semantically distort results as a quick response. Long-term memories are coded acoustically, true or false. Well, hopefully here you've got false. And by way of evaluation, strengths, this was a lab experiment with high levels of control, so it's possible to repeat the study easily, improving its reliability. The research findings support Conrad's 1964 study that information is stored acoustically in short-term memory and so increases the reliability of the findings. Baddeley's study paved the way for further research into short-term memory and long-term memory. Limitations. This was a lab-based experiment and the results may not be generalized outside the setting. Remembering lists of words is only one way in which we use memory in everyday life, so the study lacks construct validity, i.e. it's too narrow in its focus. The study lacks mundane realism, as in real life people rarely learn words, therefore the findings cannot be generalized. Brandimont et al. 1992, the study found that information is also stored visually in short-term memory, and under certain circumstances is more effective than acoustic coding. So Baddeley's research may have exaggerated the importance of acoustic coding in short-term memory. So far you've only been asked to answer short questions. In the exam you'll be asked to answer an extended response question. So for example, discuss research into the difference between short-term memory and long-term memory in terms of coding. This is for 8 marks. 4 marks of AO1 and 4 marks of AO3. The specification outlines that an extended response is evidence of sufficient length generated to allow students to demonstrate their ability to construct and develop a sustained line of reasoning, which is coherent, relevant, substantiated, and logically structured. Questions in general follow 2 styles: describe or outline and evaluate, discuss research studies for 12 marks. Discuss explanations of behavior and refer to the scenario given in the exam. All extended response questions follow a similar pattern and format and will require you to demonstrate at least 2 of the following 3 skills. AO1, demonstrate knowledge and understanding of scientific ideas, procedures and techniques. AO2, demonstrate knowledge and understanding of scientific processes and techniques and apply the theories. And analyze and interpret and evaluate scientific information, ideas and evidence. So, using the following phrases and studies, complete the table below. Okay then, so for short-term memory, the phrase 7 plus or minus 2 for capacity, duration 18 to 30 seconds, encoding mainly acoustic. The study, Miller's magic number, for duration, Peterson and Peterson's trigrams, for the encoding, Baddeley's acoustic and semantic, long-term, unlimited, duration, up to a lifetime, encoding, mainly semantic. Study and duration for long-term memory, Barrick's high school yearbook study and Baddeley's acoustic and semantic study for encoding. Okay, a little break for you, obviously, if you complete the following crossword. Okay then, so 1 down is duration, 4 across is hypothesis, 7 across is mean, 5 down is encoding, 3 down is Peterson, 2 down is capacity, 6 down is Baddeley, 9 down is dependent, 11 across is independent, 10 down is semantic, 12 across is acoustic, and here we provide you with some evaluation of the multi-store. Using the emoticons below, identify which of the following evaluation points are supportive and or challenging the multi-store model of memory, and I'll leave this up to you. Okay, and that brings us to the end of this lesson.